Hi, welcome to this new video tutorial. We're going to see today one of the most requested video I've had lately, which is how to run Yolo on the GPU, and we're going to see that today using the Nvidia Jetson Nano. As you might have noticed, I haven't done video for a while, but it was August, it was vacation time for some period, and also I'm working on the video course about the Raspberry Pi and the Jetson Nano, and so I don't have much time. But anyway, here we are today, and let's see how to run Yolo on the GPU. Let me quickly explain first how it works. To run the Yolo algorithm, we need a framework, and Yolo comes with the Darknet framework. So first thing, right now we're going to install the Darknet framework. And keep in mind that we have two different Darknets, so it can be confusing if you just look for Darknet. One is the Darknet made by the founder of Yolo, PyJ Reddy, and the other one is Darknet from Alexei AB. And I found the second one from Alexei to be much more compatible with different machines, and it worked right away when I installed it from the Jetson Nano, while the other one didn't work. So I will just close this PyJ Ready Darknet. We will not use that one. Instead, we're going to install Darknet from Alexei AB. And so let's do that right now. We just opened the terminal, and I have the code to copy in this txt file. So first thing, we are going to update the libraries. So sudo apt-get update. And by the way, this code that I have here on the txt file, I'm going to put it on the blog, so you can just check it on the link below the video. So let's paste this sudo apt-get update. And of course, we need to put the password of administrator of your system. And let's wait till all the updates are done, and then we go with the second line. Second, we need to export the cuda path. So we have these two lines. So cuda is the, let's say, the software to run the GPU. Let's put it this way: the software to run the GPU. And for some reason on the Jetson Nano doesn't have the default path that works with Darknet, so we need to copy this one and export. So these two lines, and press enter, so that we are setting this path of cuda for all the users of the Ubuntu system. And then once we have this, we can install the Darknet. First, we need to copy the folder from GitHub. So with this code git clone, we're going to copy the folder. Let's put the code right here. And so we have the folder, and if we check just here, you should see Darknet. Okay, so what I do now is we enter in the folder Darknet, and by the way, you see the Windows bar because I'm accessing the Jetson Nano remotely from my computer so that I can record the screen. That's why you see me on Windows when I use this. So let's access the Darknet folder. So cd for change directory, and then Darknet. And now once we're inside the Darknet, we need to download the weights file of the Yolo algorithm. So we copy first Yolo 3, this one. So this is the train model of Yolo 3. This is the entire version of Yolo. And then we're also going to download Tiny Yolo, which is the smaller, faster version of Yolo. So I'm going to pause the video until this one is done. Okay, let's now download Yolo Tiny. So we copy this one and press enter. And this one is going to be much faster as it's much smaller. Yolo is 236 megabyte, while this one is around 45, or close to that, no, even less, 34 megabyte. And now, once we have this, we need to change the settings of the Darknet make file before compiling it. So you can either access here from the terminal, so you can either do sudo v make file, this one, or you can just go on the Darknet folder from here and you see the file make file, and you click with the right button and you open it with the Vim terminal. So now we need to change the settings, and here we see GPU, cuda, and a few other things right here, and we are interested in just 3 of them. So 0, it means it's not activated, and 1 is to activate that function. GPU, of course, we want to use the GPU, so we're going to activate this one, and we're going to put 1. Then cuda, it means cuda, so for the Nvidia GPU this must be activated. Then we have this cuda half, which is written here that is going to speed up 3 times this, but it only works with a faster GPU than the Jetson Nano, so we don't have to activate this one. And then OpenCV, we want to compile it also for OpenCV, so we're going to put 1 right here. And then there are a few functions that we are not interested about, at least at the moment. And with this, we now press ESC and then Shift and then Z to save the file. Once the file is saved, we just type make. And now in this way we are compiling the library. It should take a couple of minutes. So I'm going to pause the video. Well, I guess it takes a bit more than a couple of minutes, probably up to 4 or 5 minutes. Anyway, when we see these long lines without any error, it means that installation was done correctly. Now it's the moment of the truth. We're going just to test Yolo. So I'm going now to clear the windows here, clear the terminal. And keep in mind that to use Darknet, we must be inside the Darknet folder. So if you just open the terminal from scratch, let's see, this way you just open the terminal. You just need to type cd darknet. And now we can run the Darknet using the code that we find on the GitHub page. How to use, let's see this one. And here are all the command lines to use the Darknet. Different situation, like for example, just loading the video or loading from the webcam. Save the file with the result. So now we try with the webcam. For the webcam is this one. So what we need is all this line, except that this is not X, this is for Windows. So if you see on Linux used /darknet instead of darknet.x, so we are going to copy this line. I will copy it slowly so I can explain everything that it's here. Let's make this smaller. Okay. So we say /darknet, we load the detector demo, and now we need to define Coco data. Coco data is the names of the object that we're going to detect. It contains 80 objects. CFG Coco .data, then CFG, and all these files are just inside the Darknet folder, so you don't have to do anything with this. Then Yolo version 3.cfg, and this is the configuration file of the training model Yolo version 3. And then the weight file that we have downloaded before, Yolo 3.weights. And then camera, we define C0, which is the first camera. If you have different webcams, you can change the index, 1 for the second, 2 for the third, and so on. And now we press enter. Okay, now Yolo is loading. Let's wait a few seconds and we should see the camera on the screen with the detection. And keep in mind that for me it's a bit slower than normal, as I'm recording also the screen. I am remotely with Windows, so it's a bit smaller than usual. Okay, first we have normal Yolo. Correct detection, person, which is me. And here on the left side we can see FPS, frames per second, and the objects detected. So let's take some other objects, like for example the bottle, the pen. It's a bit slow in comparison with the other camera. Okay, I'm going to shrink a bit my camera on the side so you can see better the other one. Okay, bottle is detected correctly, the pen it's not. Knife, okay, knife. Then let's see the phone. We have cell phone. Then I take a small dictionary that I have about Italian Polish language. Toothbrush that I don't see anywhere. Let's see if at least book detection or anything like this. Anyway, what you might have noticed is that it's really slow. We are able to get only 2 frames per second, and that's probably, it is going to disappoint many of you, as I was disappointed myself. But you need to keep in mind that this is still a cheap, small device, the Nvidia Jetson Nano, for only $99 plus few extra things for the case and the micro SD and the power and so on. But it's still a cheap device and it's a good result. But this is the heavy Yolo. This heavy Yolo on the computer machine with the CPU runs even slower. Let's instead go and check how fast is the tiny Yolo on the Jetson Nano with the GPU. So I close this one, press ESC, and now let's find the one regarding tiny Yolo. So here you see tiny Yolo, and so let's copy this one. It's okay, let's type it. I'm going to clear the rest, clear /darknet, and then detector demo, and then cfg coco.data. So we are still going to detect the same 80 objects from the Coco datasets, and then cfg Yolo version 3 tiny .cfg, and then Yolo version 3 tiny.weights, and then also we want to load again from the camera, so we say c dash c, okay, probably without the dash, no, dash c0, and we press enter. Okay, now it is going to load the tiny Yolo, and I'm going to try the same thing with the same objects. Let's again move the, okay, let's put the terminal to the right so that we can see the informations. Okay, I'm almost there. Okay, what you can notice is the frames per second, which dramatically increased. We are now going to around 16 frames per second, which is not that bad for the GPU. It's not real time. To have like completely real time, we should have at least 25-30 frames per second. But it's already reliable to use it also in some work environment if we want to detect some specific object passing somewhere. It's good enough, this speed. The other disadvantage is that tiny Yolo is not as precise as the Yolo, and now it's not detecting anything at all. Let's just do some quick tests with some objects I will take from pictures, and let's see what we're able to get. My original idea was now to take some picture from the phone, show it, and detect the objects, but for some reason, like I cannot get the tech to remove the autofocus from the camera, so the picture is not really clear here. So instead of doing it this way, I have some other and even more interesting idea. You can see here after webcam, we can use also net video cam. So what I'm going to do, either you can use an IP camera, or either with your smartphone, this is Android, but also with the iPhone you can do the same. You install an app called IP Webcam, and I also showed in another video on my YouTube channel how to install this app. You can check about IP Webcam, something like that. And we're going to stream what we see from this camera. We're going to stream it to the Jetson Nano, so I'm going to show out of the window, and we try to detect some objects in real time. So IP Webcam, I start the server, and this is connected to the same router where the Jetson Nano is connected. So here there is the IP written where I have to connect to receive the video stream. So what you see here there is also an IP. I'm going to put on this long code, I'm going to change the IP address with my IP address from the phone. So let's quickly copy this one. No. So from detector to MJPG, and I'm not able to detect to copy these two lines. Okay. Then okay, I already have the terminal, so I go on the terminal and I type /darknet, and then I paste the code, and I need to change the IP with my IP, which is almost exactly the same. Instead of 80, it's 14, the last 80, 14. And also okay, and also we are going to use Yolo version 3 tiny, not the normal Yolo, because normal Yolo is too slow. So instead of Yolo 3 weights, we say Yolo 3-tiny, and also in the configuration file we use tiny. and let's run it. Okay, now it's loading the algorithm. Okay, interesting. Everything you see here, it's what is coming inside my webcam. So I'm now going to open the window and let's see what we can detect outside. Okay, I'm not sure this was able to detect anything at all. There wasn't much to detect, probably. Okay, now we are back to my station. So here is where I'm doing the recording. Anyway, I'm going to stop this one. And so I hope you enjoyed this lesson, and maybe you might have something better to detect than what I had today. And I will post some new interesting videos soon, and for the moment you can stay updated about the video course and all the things about the Raspberry Pi and then Jetson Nano. See you in the next video.